So today, we're looking for those things that differentiate, one system from another. And what we find most of all is the ecosystem. It's the ability to stay in a common environment and to leverage all the different tools that you need, and then to share that data seamlessly between those different tools. So that's what we're going to focus on today, and we're going to do it in the context of SolidWorks CAM. And so that's not what I wanted. Let's go ahead and bring up our part. And the big thing that we're going to talk about, there was a huge change about 3 years ago, and that's when SolidWorks licensed the CAMWorks software. And what they licensed was a package called 2.5-axis Premium. And a lot of misunderstandings out there. A lot of people don't think there's any 3-axis capabilities in there, and there are, and we'll look at those today. But then we'll also look at what differentiates SolidWorks CAM Standard from SolidWorks CAM Professional. And, it's important to note, so this, what we're looking at right now is we're looking at a single part in the part environment, and this is going to be the basics for SolidWorks CAM Standard. And I would say for somewhere around maybe 10 years that this was the majority of what we sold. And it had a sale price back then just under $6,000. It was $5,000 and $750 for the annual subscription. And today this is included at no charge with your SolidWorks. And so when people don't think there's, or when they aren't aware of the real value that's being given to them, and they don't take the time to learn it and use it, then they might miss out on something really great. So we turn on SolidWorks CAM with the add-in manager, just the same way we do with almost all the other add-ins. And you look down here and we've got SolidWorks CAM 2020. And we've told it to come on, to be active now, and to be active at startup. And when that occurs, we get these 3 tabs over here. This is going to be our SolidWorks CAM feature manager. This is going to be our SolidWorks CAM operation tree. And this is going to be our SolidWorks CAM tool tree. And so the way we're going to start here is we're going to walk down this row of icons. And I do want to let you know that I've changed this row of icons just a little bit. I've streamlined it. And I've kept the things in there that I want. And I've kind of ignored the things that I don't normally use. For me, I always start with defining the machine I'm going to use this, or I'm going to cut this part on. And so I look at my list of machines, and the spectrum of SolidWorks CAM will handle 3, 4, and 5-axis mills, and it'll handle 2-axis turning machines. So we're going to start out on our 3-axis mill. And we'll go over and we'll just accept the default tool crib that it's chosen for that mill. We're going to go and we're going to choose one of our CAM-specific post-processors. It's important to note that, as we said, we've been in business for about 28 years. In addition to representing the full SolidWorks line, which we love and we're very proud of, we also do have the full CAMWorks line. And we'll talk a little bit, too, about how CAMWorks extends SolidWorks CAM. We've got a couple brands of 3D printers, Markforged and Big Rep. And then we do have a full machine shop. It's a small machine shop. It's here primarily to support our customers. And we do some work for our customers, and we'll do things like turnkey and also training sessions, including the machines. But it also helps us to stay sharp, because when you're actually cutting parts, you might actually break a tool. For 20 years, I never broke a tool inside the CAM system, but since we've had the machines, I've broke a few. And so this is a post that Brian Suchlin has written, and Brian is our post guy and one of the top, several guys in the whole world for SolidWorks CAM and CAMWorks. We'll go ahead and we'll select that post. Here's some defaults that Brian puts in his machine, and we could modify these things. And then we'll go to our setup and we'll define, the first thing we're going to do is we're going to define our fixture coordinate system. And so we can do this based on a pre-existing SolidWorks coordinate system or based on a user-defined coordinate system. And then we could use either a part bounding box or a stock bounding box, to represent that. And we'll just start out and we'll say we want to put our 0 point at this point right here. And then we can tell it which direction we want our axes to go. And so we'll make our x-axis aligned with that edge right there. We'll make our y-axis aligned with that edge. We can flip the direction, gets our z going up in the right direction, and we'll say OK to that. And then we'll say OK to everything else. Next thing we're going to do is going to go into our stock manager. And it's important to know, this is a part we're actually cutting in our shop. And if any of you guys want to come over and make some chips later on, we'll be doing that. So in SolidWorks CAM, you've got a multitude of different ways that you can define the stock. You could use a stock bounding box, and we could go down and we could add stock to any different axes. We could use an extruded sketch, and that might work for like a flame cut part or a laser cut part or something like that. And we could also use an STL model, and that STL model could represent work in process, it could represent a casting or a forging. And then lastly, we could represent the stock with a part file. And that part file could be a configuration or a different configuration of our current part you see on the screen. So we're going to go ahead and we're going to take this default method of stock, the box bounding. We're going to go over here and we're going to say that we want our machine or our stock to be based on our fixture coordinate system that we just set up a moment ago. And I know that I've got about 50,000 stock on my X direction. And it's uniform in both directions. So I can hit this little button and it makes it so. I've only got about 10,000 stock in my Y direction. But once again, that's uniform and that makes it so. And you can see down here it's populating the actual sizes of our stock. And then on my Z, I'm going to have about 20,000 stock on the top of the part. And then I'm going to be holding it with about 120,000 stock. And maybe that's actually about 130. And so there you can see my stock, and what I bought was 5 by 1, and we cut it to about 5 inches and 100 thousandths, or just under that. And so now that my stock's represented and my machine is defined, then we do want to let the system know we're going to change our coordinate system. In this case, we're going to use our stock bounding box, but we will use that same point right there. So we say okay to that, and now we're all good to go. And if we were in an old traditional CAM system, we'd probably go over and we'd pick the tool that we want to use, and then we'd start picking the operation that we want to use. We'd start picking some boundaries and things like that. And it's important to note that I can copy that same workflow right here. But we also have a tool called automatic feature recognition. And automatic feature recognition is the power of solid modeling taken into the CAM software, into machining, and that's where the software has the ability to interrogate the part and return back the features that it thinks it needs to make in order to create this part. And we have some control over which features it looks for. If we go into our SolidWorks CAM options, we go over to our mill features, we can tell the software to look for holes, non-holes, bosses, face features, and we're going to go ahead and we're going to turn on part perimeter features. And when we look for part perimeter features, we could have a boss type, and that might be like if we were using a router or something like that, or a laser, and you only wanted to cut out the outside shape, then you'd say just treat it as a boss. But if you were using a mill, we probably want to rough that stock away before we do the finishing passes on the inside. So we'll treat it as what we call an open pocket. And that just means it's kind of the reverse of a contained pocket. The pocket goes outward rather than inward. And that's all we're going to really need. There are some other things here, some tapered and filleted pockets, curved features for chamfering. And then we've got some defaults that allows us to tell the system how we want to treat those features that we find. If in our shop, we're rarely going to drill anything over about 3/4 of an inch. So I can say that my max diameter of a hole is 3/4 of an inch. And then what SolidWorks CAM will do is if it finds anything bigger than that, it'll automatically treat it as a circular pocket. I could say, hey, you know what? If you find something that's got at least 181 degrees of included angle, then I want to go ahead and drill that and treat it as a hole. If we said, hey, we might have a hole that has an interruption in between, we check this condensed split holes, and it'll make one long continuous feature for that. And then we could also say, hey, if you find a hole that is below the top surface of the stock, I just want to automatically extend that hole up to the stock. And a lot of times, we're going to try to drill our holes first before we go in and machine, so that we have, we know we're drilling from a good, even, flat surface. And we've got some other things in here, but that's the majority of what I use. So we'll go ahead and we'll say OK to that. And if we say apply to all possible, it'll change those system defaults, and those will be there for me when I use them in the future. So getting back to this tool, extract machinable features. This is it's a very powerful place to start. We're going to go ahead and select it, and you'll see that it's initialized this automatic feature recognition engine, and it's interrogating the part. In about a moment, we're going to get a setup direction, and we're also going to get some features underneath it. And so here you see we've got mill part setup 1, and the little arrow, that's our Z direction of machining. We've got a face feature, and it's consistent with what we defined the stock to be above the part. And you can see after the feature, there's what we call a strategy or a rule. And here it just says finish. And that just means in this particular case, we're going to take a face mill and we're going to finish the top of that part. And now we've got an open pocket. And as we said when you find a part perimeter feature, treat it as an open pocket. And you can see we're just going to rough and we're going to finish that. And when you see on the screen, you can kind of see some solid lines and some dashed lines. The solid lines represent the fixed edges of the part. Those are the things that you better not violate, or else you're going to scrap your part most likely. And then the dashed lines represent the open air edges of the part. And that is the places where we actually have to machine beyond them if we're going to make the part correctly. You can see the system knows where the bottom of the stock is, and it's automatically extended that feature down to the bottom of the part. Now, the only problem is I know, and again, we're looking at the free version of SolidWorks CAM. There's a lot of tools, a myriad of tools, clear up through 5-axis simultaneous, assembly machining. We'll look at some of those things in a moment. But we're looking at what comes free at no additional charge with your SolidWorks subscription. And so in my case, I know I've got some clamps down here in the real world, and I'm going to show you that setup in a few moments. But I can go in here and I can edit the definition on that feature, and I can say, hey, instead of going to the bottom of the stock, I just want to go to the bottom of the part. And maybe I want to offset that down about 5 thousandths. So I can key that value in, and you can see it changes that depth or displays that depth, and it actually shows us, that representation of where the cut's going to end. So we'll say OK to that. And now we've got a circular pocket here, and totally happy with that. We've got a countersunk, we've got a hole group here. And now in this particular case, these holes are, I know, threaded holes. If we were to use the hole thread wizard, then it would automatically find those threaded holes. But if we want to change the rules, it's as simple as going into our parameters, changing our strategy from a drill to a thread. I'm going to be doing some roll tapping on these, form tapping, and I can go into my library, and I know these are some 832 holes. I say OK to that, and it's going to then automatically assign the strategy for making those 832 holes. And then finally, we've got a countersunk hole in the middle here. And then you can see the thing it didn't find with feature recognition. And we could go in, by the way, and we could say highlight recognized faces. And it would show you everything that it recognized. And then whatever is not highlighted would be the unrecognized features. And so it did not recognize this 3-axis feature here. So we can very easily right-click, and we could say insert a multi-surface feature. I'm going to go ahead and I'm going to say select all and associate. By doing that, it tells the system, I want you to consider every feature on the part. And that keeps me from running into a situation where I might violate one of the faces of the part. And we say OK to that, and it will automatically apply this area clearance and Z-level cut strategy. Now in this Z-level cut, I'm going to show you something that changed last year. And it's a very, very, very powerful change to the software, but we'll save that for a little bit further down the road. So we've got all these features now, and if we look at the features on the back side, we've got on the back side a face feature, and once again, it knows how much stock is there. We're not going to need that open perimeter pocket on the back side, because we will have already roughed away that stock, and we're going to be holding this in a soft jaw afterwards. So we can take this guy. We don't really want to edit it. Let's take it, and let's just suppress this feature. And then we've got, in a regular pocket, this is going to be a little slot where a locking pin goes. And then finally, we've got a hole group. And once again, we don't really need that because that's the feature recognition saying, hey, I found an arc with more than 181 degrees of circumference. And we could, if we wanted to, we could use this as a start hole, and that would be fine. But in this case, I'm just going to suppress this guy as well. So, and then when we suppress it, you can see it kind of grays it out. Let's go ahead and take this first setup. We're going to tell it that we want to generate our machining strategies for making this part. So it takes those features out to a database, and that database is totally customizable. You can change the rules, make them so that they fit with your company, and then it kicks back all the different features that we've told it we want to use in these situations. And then you can see these features turn black. And that tells me that I've found rules that satisfied the feature, and I've got operations waiting. And now I can go over here, and I could start to work through these on a one-by-one basis. So if I wanted to go in and say, edit this face mill, I could go and I could first look at my tool, and I could go and I could change some things about my tool if I wanted to. I could go and I could look at the holder that I'm going to use. I could look at the feeds and speeds that I'm going to want to use. I could do those feeds and speeds by library or by operation, or I could save them with the tool, which is what I often do. I've got this feature that I'm going to be cutting, and I can change the strategies for how I cut that feature. I can also tell it how much I want to cut per pass. And I'm just going to say I can easily take an 1/8 inch with this cutter. If I hit the F5 key on my keyboard, it's going to go ahead and it's going to give me the initial tool path. And if I want to go back and make some changes, I could do that. I could say, hey, I want my max step over to be 90%. I'm not taking a big cut. Hit the F5 key, and it changes that tool path. I could go back and change the side steps and things like that. And so we'll just run with those defaults that we had in the first place and say OK to that. And now you can see that it's wanting to rough out that outside and finish that outside. Well, I'm going to save that for last. So I'm going to drag these guys down to the bottom, and then I'm also going to change those tools in a moment. But the truth is, I could go through at this point and I could kind of tweak everything, or I could just say, hey, generate my tool path and let me see what you've got. We go through and do that, and then we'll make some changes to these 3-axis cuts in a moment. But we've got our face pass, we've got our roughing pass in here, and that looks just fine. And now on this finish pass, I'm not going to have it start at that hole center, so let's go into that and let's change that feature. I also think we can take that in one pass. So let's make our first pass, and you can see we can define these passes by a percentage or by the actual data. So let's go and we'll say, hey, you can go 1 inch deep on this guy, max cut 1 inch. If we hit the F5 key again, updates that tool path. If we go into our features, we can tell it, hey, we don't need to start at the hole center and we don't need to end at the hole center. Again, hit our F5 one more time. We've got a little overlap in there, but I'm pretty happy with that tool path. And then we've got, we're center drilling those guys. Now here, we don't really center drill very much. We like to use 135-degree tip tools and just let them go at it. So I'm going to go ahead and I'm going to suppress that guy. And then here's my tool and here's my tap. If you look, it's drilling a little deeper, tapping a little shallower, but I might like a little more clearance. So we can go in and we can override these features anytime we want. So let's go to this feature depth. Let's go and let's tell it we want to override that. And let's take this guy down to 650 thousandths instead. Once again, we can hit the F5 key, updates our tool path, and we're just fine. And so once again, I'm going to get rid of this center drill. And you can see that this is a case where it's going up to that stock depth. So in this particular case, we really might not have wanted to have done that. So, but we'll leave it for now. And we could change that guy as well. And then here's our countersink. So, in fact, let me go back. I'm going to change that feature real quickly.
Hey guys, just so while Jeff's doing that real quick, this is a interactive. So if you guys have questions or anything along the way, just make sure you ask. Okay.
Thanks, Don. Anything coming up for you so far? Anything that's not clear that I could elaborate on?
Did you unmute them so they can talk? Or?
Yeah.
Everybody good
so far? Everybody's
okay.
I'm good. Yep.
All right.
Good.
Go ahead, Jeff.
Okay. So we went ahead and we changed that feature and we made it so that it was only going up to this face instead, which is probably something that we'd want. And so for the moment, I'm going to suppress this guy as well. And then we'll take a look at what we've got so far. So we can go in our simulation, and then here's our block. If we want, we could leave that block solid. We could go in and we could say, hey, we really want to see a translucent representation. We could turn on our shaded part underneath, and then we could tell it, hey, let's just run to the next operation. We could slow it down. We could tell it to update the stock every one move. And we could see our tool when it's doing a rapid move, and then when it changes to the tool color, we know we're doing a tool move. We can also change the representation, the quality of the cut that we see. So we can slide that from a speed bias to a quality bias, and the same thing with the turbo mode, and the same thing with the comparison. So let's say OK to that. We'll let it go back and restart that simulation. And then there's our facing pass. And now for me, I kind of like seeing the putt underneath, but I also kind of like just seeing the stock cut away. So at any point in time, we could turn that part off. We could go back to a shaded display. And so there's our roughing pass. And now maybe, with that roughing pass, one thing I see is that maybe I want to spiral into that work instead of plunging into that work. Here's our drill. Here's our tap. If we rotate it over, we can see we've got some clearance down there from our tapped holes. There's our drill. There's our countersink. And now, I don't want to do this outside with a 1/4-inch tool. So let's go ahead and we'll stop this guy and let's look at what does it take to change a tool in the middle of a process. So we come down here and we look, and here's that 1/4-inch tool that it chose. We can change the defaults on this. You can see we've got a lot of cuts there to get down there. Just no reason to do that whatsoever. We're already using this 3/4-inch cutter. So if we wanted to use that same cutter, we could just grab this guy, drag it down, drop it underneath there, and it automatically recalculates that tool path. And then the same thing for the finish pass. Maybe instead of using that 3/4-inch, I want to use my 1/2-inch cutter. And I could drag that guy down and use my 1/2-inch cutter right there. And so and then really, I know I'm going to be pretty happy with my simulation so far. But one of the big things is we want to kind of look at this this three-axis machining. And first of all, I know that I've already roughed away a lot of these things. Now, one of the things that you get into with the higher levels of the CAM software is rest machining, but it's not present in this free version. But what we can very easily do is create a contain area. So we go in and we say we want to add a new contain area, and then it would either allow me to begin picking off of the model, or I could just simply go pick a sketch that I've predefined in the first place. So I've got a sketch here, and I know with this particular feature, I really don't want my tool going beyond this edge here or beyond these edges, but I'd kind of like for it to drop into this edge and give me a little bit more of a radius there. All this is a clearance area for a cable that comes through. So I can go down here and say, hey, when you see that contain, make sure you stop on the curve. And you can see you can go up to the curve, on the curve, or past the curve. So we're going to stop on that curve. We could also offset that if we wanted. And so there's a lot of flexibility. You can even assign, 3D shapes or 3D depths to these curves as well. So let's say OK to that. And I really don't want to change my toolpath just yet, because this is a case where I don't want to use that 3-axis operation, or that 3/4 tool rather. I want to use my 1/4-inch tool. And so there you see, we've gone ahead and it's come in. And then one other thing that I really want to do is, I know this is a 5/16 slot. And so what I really just want to do is I'm going to insert a feature over here, and we're going to say, hey, new 2.5-axis feature, and we're going to take and make an open profile. And I'm just going to choose this line right here. My end condition, well, it's going to be half of 5/16, so 5/32. So we're going to tell it we want to go 0.156 deep. And it changes that. You can see we've got an angle that tells it which side we're going to cut on. And we will just use this finish strategy, or we'll say a fine strategy. So it's chosen a 1/2-inch tool. We can change that. Let's go over here to our tools. Let's add a 5/16 ball nose if we don't have one already. So we'll say add tool from library. We're going to add a ball nose tool. We're going to look for something that's 150 thousandths or bigger. And here you can see my 156 down here. And we are going to take we'll just use a 2-flute ball nose for that. We'll say OK to that. And then we could take that finish pass, and we could go and we could switch it to this tool that we're using right here. We could also just go into that pass. Let's go ahead and say generate our operation plan. Let's go and we'll edit this guy. So once again, this is all the stuff that's included at no extra charge with the software. Let's go down, let's grab that ball nose tool. We'll take the corresponding holder. We're going to do a parallel lead in and a parallel lead out, and I'm going to lead in about 72%. If we hit the F5 key, it's doing it in one pass. I might want to do that in 2 passes. So if I go to my contour tab, I could say, hey, go 25% at a time. And now it makes 2 tools, but I'd rather, I'm going to be climb milling and conventional milling all at the same time. So I'd rather zigzag that guy. And now it's getting closer, but I've got a little bit of a retract in there. So if I go back to my lead-in tab, I can say, hey, on my cut depths, I want to stay down. And now I've got exactly what I want. And we could even step through that tool path, and you can kind of see what I was hoping for in that case. So it comes down, rapids down to my clearance plane, feeds down to my first depth, cuts across that guy, feeds down to my next step, cuts back, and I'm just stepping through this stuff, and then it's done. So I'm very happy with that in this particular case. So we'll say OK to that. And we could sort these operations out in a moment, but for the moment, all I'm really worried about is let's just kind of get the basics done. And so now I've got my 3-axis cut over here, and I'm ramping into that work. And I really don't need to go down to this area here. So what we might do in this particular case is give it an avoid area. And so if we right-click and we, just for the sake of time, I'm going to let that thing stand because we want to jump into something else in about a moment. So we're going to go into our Z-level cut, and we're going to tell it that we want to do about so let's go over to our Z-level cut here. We are going to leave our deviation at about a 1/2 thousandths. We're going to tell it we want about a 20 thousandths cut, stepping over. And then we're also going to tell it to do a thing called a combination cycle. it's going to look for the shallower areas of the part. And we can preview that toolpath. Now it's got something that it doesn't like there. So let's find out what that is. I'm going to go ahead and I'm going to put my contain area in here. And I'm going to tell my tool it can go right on that curve. And there's my toolpath there. So if we go and we take a look at this guy, let's run through our simulation real quickly. I'm going to let it run to the end. This is a real good time to ask questions. So if anybody has anything that's not clear to them, please go ahead and ask. And you know, we might want to do that. We might want to do that roughing before that, so we aren't going down and we'll speed this guy up. But again, the main point of this whole thing is to kind of look at, you know, what am I getting with my free SolidWorks CAM? And this is one area that people are really unaware of the functionality that they actually have there. So there's the outside of my part. If I wanted to quickly finish the rest of my part, I'd go ahead and I'd say generate my operation plan. In this particular case, I don't need to rough this guy out, this little slot, so we'll get rid of that. Let's go and we'll say edit definition on the slot on the other side. We're going to change this tool on the fly to a 156 flat. We'll say we got about a 1/2 inch of flute length, about 2 inches of overall length. We've got about a 1/2 inch of shoulder, and the shank is going to be also 156. The preview, and let it go ahead and create that toolpath. And then, and we might actually, we'll go ahead and we'll apply a helical. Okay, so I wonder what the holdup was. It's saying, hey, I can't find a safe way to get into this work with the arc lead-in that we've got. So we're going to turn off the gouge checking. We're actually going to say none on our lead-in. We're going to go over to our feature option. We're going to tell it we want to do a spiral in. We're going to do about a 20 thousandths radius, and we're going to do about a 50 thousandths pitch. And then if we say select entities, we can go in and we can say, hey, we want it to start in that center right there, hit the F5 key, and there's our toolpath. And then we can change or add that tool. I want to add that tool, so we'll go ahead and accept that. We'll do our facing before. And just like before, let's go ahead and change that depth. And when we say OK, it reruns automatically. So let's go back into our final simulation here. And let's tell it to run to the next setup. We're going to let it run real fast.
When you edited that depth, did that just change the toolpath, or did that affect the feature as well?
That's a great question. I love that question. That only affects the toolpath. It does not change the depth of the feature. If we wanted to change the feature, we'd actually have to go back to that feature and edit the feature. So there's our part. You would just right-click and say Edit Feature.
Feature.
Yep. And so now we're going to let it go to the next operation. We'll slow it down a little bit. So we flipped it over. We've got it in our soft jaw. Face it off. And then we cut our slot. There's actually a corner round on here too, but we'll save that for now just so we can jump into some other things. And that's essentially our part. And then the last thing is that, you know, this would be the situation I've created here would be if I was running multiple vices. So all I've got to do to set it up to run multiple vices, go in, go over to my offsets, go to my work coordinate offset. I'll tell it this is 55 and say OK. It regenerates that toolpath based on a G55. And this one will automatically default to 54. See, we don't even have to go in and say it's 54. So let's save this guy. And it's only, I'm only saving it because it's a real part I'm actually going to be cutting later, and I don't want to make that change to it yet. So we'll just call it test.
Is that multitasking, Jeff?
Yeah, I am actually kind of multitasking.
Getting your work done at the same time. I kind of like that.
Yeah, yeah. Okay. We'll close the original document. All right, and then the last thing we want to do is let's go ahead and generate our toolpath. So we'll say post-process. Let's just call it this test. And we can, we'll tell it in our options, we want to see our G code when we're done. And we can just tell it to process in the background. So it processes that toolpath. Otherwise, we could watch the code actually scroll by here, and we could see the moves on the screen. When it's done, we hit the green check. Our toolpath comes up, and there's our toolpath. We could also go into our backplot and backplot this guy, and then we could even assign, you know, our different work coordinates in here as well. So, any questions on machining in the part environment? This is about the extent of what you could do with the free version of SolidWorks CAM Standard. Any questions on that?
Does it have any?
We've got it.
Is there any questions in the chat? Go ahead.
Yeah, go ahead.
Is there any high efficiency milling strategies in the free version?
You know, there's really, been a while since I looked at that. I want to make sure before I say no that I'm not saying something wrong. So in our roughing strategies, we've got, it's a little bit misleading because volume mill's in the higher end version. It's only because I'm licensed for everything under the sun, right?
Gotcha.
But you could do a spiral in or spiral out, and that would add some efficiency to it. But in general, what you're going to get is pocket in, pocket out, zig, zigzag, spiral in, spiral out, plunge roughing, and offset roughing. And then volume mill is saved as an incentive for the higher end version of SolidWorks CAM Professional. But fortunately, that's what we're going to look at next. And then finally, you know, we did say that we wanted to spiral into this guy. So let's go in. We'll do let's do a 150 thousandths diameter. We'll do, or rather, the pitch 100. We'll make that 150, and we could just say, you know, start at the whole center, hit the F5 key, and we'd have that lead in there. Okay, so so this is, you know, I mean, again, this is miraculous. This is over $5,000 historically of value included at no additional charge. At CAMS, we write the post processors, and so we can give you a great post processor that has most, you know, that has every safeguard we know to put in that post. If we jump up into that higher end version, and here I'll actually show you, you know, this is the job that I'm setting up to run later on today, and you can see I was trying to bring in my part that we just programmed here. I've got this thing set up to run some soft jaws in a few minutes, and I've got a, you know, I didn't show my 1, 2, 3 block, but I would put a 1, 2, 3 block in between, 2-inch side, you know, close my jaws up, and then I'll cut these shapes out for that flip for the soft jaws. But here you can see we've got our, you know, our Mighty Bite clamps, and this is our first operation here. We're going to take, there's 2 halves to the part. We'll do a flip to the left, and then here I actually went ahead and showed some, you know, I ran feature recognition. I told it in this particular case that my jaws were the things that I wanted to cut, and then I allowed it to do, in this case, a volume mill roughing on this. And I did a little rest roughing as well. So in my simulation, I told it, you know, I only really cared about seeing, you know, the table and these particular vices because I'm not doing anything else with the other vices at this moment. And so it comes in and traditional volume mill roughing, a little bit of rest roughing, and then also finish pass. I can run through a whole programming in the assembly mode if you want. But, you know, for me, some of the things that, so, you know, if we talk about what do we get with SolidWorks CAM Professional? Well, with CAM Standard, we said we get, you know, 2.5 axis plus milling, so some light 3-axis, and that would include like a Z-level rough, Z-level finish, that combination cycle that we saw, and then also a flat area machining. When we jump into the SolidWorks CAM Professional, we get the ability to go into the assembly mode, and the benefits of that are that, you know, it's you're in the ecosystem, first of all. We can use that assembly to generate things like soft jaws. You know, we can look for interference. So one of the things, you know, it's nice to kind of know how high our Mighty Bite clamps are going to come up and how much space we have, you know, as we cut down, you know, before we might have an interference condition with that Mighty Bite clamp. You know, we can also look at when we're drilling, you know, is there a possibility that we're going to hit, you know, our bolts, you know, in our soft jaws? And so that all becomes very nice. You also get the volume mill toolpath, and then you get turning as well. And so do you guys want to see, you know, a quick run through of a milling in the assembly mode and what's a little bit different there? Or do you want to just see a quick turn part, or what would you like to see?
Hey, Jeff, real quick, just to throw it in there, the Professional will also give you 4+5 indexing, and it also gives you CAM configuration support. So in the same part file, you can program your lathe and your mill. So just two other things, the differences between the Professional.
Yeah, thank you, Brian. I appreciate you adding that in.
You're welcome.
Yep. Awesome.
I would like to see the assembly, and this goes something, Don, for our presentation coming up in May. This integration right here where we can see everything and then verify everything is really critical to us.
Great. Okay. Let's take, you know, this is a pretty involved part doing all these guys. And so let's go ahead and let's jump into something that's just a little more straightforward. And again, you know, you make a good point, Brian, that we can bring this into, Brian, that we can bring this into our G-code verification as well. So if we wanted to program this guy, I'm going to go over, and the very first thing I'm going to do is I'm going to manage my parts. And the reason we do that is that we've got a bunch of solid models on the screen, and we want to let the system know what do you actually want to cut. So we right-click, we say Manage Parts, pick that guy, and that's all we need right now. And then the next thing we're going to do is we're going to define our stock. So we go into our stock manager, and you know, we could use this box bounding, we could use an extruded sketch, we could use an STL, but in this case, so much easier just to go in and say, hey, I want to choose a different solid model. And this allows me to use all my common mating tools. You know, if we think back to that example I just showed you a moment ago, you know, I actually have a stock that shows what I have left after I machine that first side. And then it's very easy to display that for the second side as well. So we say okay to that. If we go in and define our machine, we're going to cut this again on our 3-axis mill. We'll go over here and you know, just take our default tool crib. We'll take our post processor, and then for our setup, we want to give it again a direction of machining. And so we'll say that we want to use our stock bounding box. I'm going to pick this center guy here, and I'm going to tell it that I want my X direction, and I could choose my vise or whatever for this. My X direction to go that way. I'm going to flip it so X positive is going that way. I want my Y direction, and I could choose off the part if I wanted to, and we'll flip that so it's going that way, and my Z is going up. So I say okay to that. I could also have the system create a SolidWorks coordinate system for me. So we'll say okay to that as well. We go in and we extract machinable features. And it comes back, and even if we had multiple parts or whatever, it's going to put everything that's in a common direction underneath one setup. And then we can even assign work coordinate offsets to the individual parts underneath that one common setup. You look and we've got our face feature, our part perimeter feature, and we might want to drag this guy down to the end. We've got a bunch of irregular pockets. And in this case, it does have our it's got our whole thread callouts on these holes, and it automatically knew to map that to the threading condition or the threading rules, if you will. With these guys, I kind of like to make some changes rather than just rough, rest rough, and finish. I'd like to use volume mill. So I'm going to go over and I'm going to say I want to change my default strategies. I look down here and it's kind of made bold the features that I have. And so I could take this guy and I could say, hey, rather than that rough and rest rough, I want to use my volume mill rough, rest rough, and finish. And then the same thing, and I can say apply, and it applies that, changes all those strategies over here. With my part perimeter pocket, my open pocket, I'm going to go do the same thing here, apply that, and say OK to that. And so now in this case, the magenta color represents the fact that I have no corresponding operations yet. So I tell it to generate my operation plans. And let's just go ahead and we'll generate our tool path. And with the rest roughing, it's going to run through these guys a couple different times to see where that remaining material is. And then in some of the cases, it did not have any remaining material to remove. And we can go in here and edit definition. We can show it our fixture. And then let's go ahead and let's sort these operations. So we go over and this is one of the reasons I kind of clean up I don't need all these guys. And so we're going to tell it we only have, and so Brian Stahl, for you, one thing that when we get into the horizontal, that's when we're going to start to look at things like strategies where we sort by and across setups. So if we wanted to drill all 4 faces of a tombstone, and we got multiple features on each face, then we can shorten that flow from across the single face and then all the way around the tombstone using these strategies.
Nice.
Over here, we'll say, hey, we want to do our face mills first, then we'll do our whole work after that, and we'll drag our countersink up above our drill, and then we'll do our roughing and finishing and things like that. We could also sort it by tool. We can apply that. Changes the order of this list over here, and if we don't like it, we can always change that. So we'll say OK to that. Let's take a look at what we've got so far. And I'm just going to let this run relatively fast. And there right away I can see, well, I forgot to change the depth on that feature. And so it's a good chance for us to look at the different depths. So here's our volume mill. And we'd probably use a smaller tool for that, quite honestly. So let's go back and let's make a few changes. And first of all, let's go back to that feature. Go to our part perimeter, edit definition. And this is going to be the same in the CAM Standard as in the CAM Professional. And this is where we've got the choice to say, hey, instead of going to the bottom of the stock, let's go to the bottom of the part. And in this particular case, I think it's pretty close, so I'm going to leave it right at a 0 clearance there. But we say OK to that. And then I believe it will have automatically rerun that for me at the higher level. And then once again, I could drag this guy down to the very end here if I want. And let's find our finish pass. And here's a situation where, yeah, I'm not very happy with that tool selection. So we're going to go over here, grab that tool. Now it works great there, not so great there. And let's drag that down to our 1/2 inch tool. And then let's move this, this finish pass down after our rough. So that's a little bit of a look at machining in the assembly environment. And then again, you could take, all of this stuff into your G-code simulation. Do you want to see me drill down any deeper in this stuff, or is that giving you a basic feel?
We got 6 minutes left, Jeff. So just.
Yep. Okay.
Was there any other questions? anybody else have any other questions or anything else they had an interest in?
No, I don't think for this webinar I'm good. I'll have a bazillion questions, but for a later date.
Is this Brian?
Yeah.
Okay.
Yes. Yeah.
We're going to have a conference call with you on Monday the 4th, and then we'll see you guys on the 6th then. So,
yep.
All right. Well, good.
Okay, so really quickly.
No other questions?
Well, we can do a quick lathe. We'll take 2 minutes, just do a basic overview on lathe.
Yeah.
So let's go and let's tell we want to do a single. And then, with CAM, SolidWorks CAM Professional, you do get a basic lathe. The mill turn stuff is all going to be in the CAMWorks environment. So let's go over here. We'll accept that tool crib. We can browse and find a post processor. And Brian, I only work with your post, Brian Suchland, so I don't even know where they're putting all these other guys. We'll take that guy right there. And let's go over here. Let's go to our chuck, and we'll just say OK to that for now. Extract machinable features. Let's add one feature in here. So we'll add a new turn feature. Let's go ahead and make it an OD feature. Let's grab this profile right here. Let's say we're going to make that a threaded cut, and we'll say OK to that. And let's put that before our cutoff. Let's go into our stock. Let's tell it we want to use an extruded or a revolve sketch, and we'll go and we'll grab that stock profile. Say OK to that. Let's generate our operation plans, generate our tool path. And we're not going to get real mired down into this guy, but let's run through a quick simulation, and let's turn off our chuck because I didn't worry about where we were putting that chuck or anything like that, and we'll just run to the end. One thing we are going to do is we're going to say that we want to use simplified threading. Let's go to our next operation. So we come in, we rough face, notice where that stock is, finish face. I'd probably finish it after I rough the OD, but I can easily drag and drop that around. I'm going to speed it up just a little bit. Multiple different grooving styles available. Thread it. You can even zoom in, and we can, of course, that's not a very good looking thread, but we can change that. And then finally cut off on the back. So that's a quick overview on that. And with that, I'll open it up for any remaining questions, or we'll wrap her up.
One quick question on the post
Any other questions?
processor. On the post processor, do you have the ability to include switches and stuff to make a global post? You know how everybody wants their coolant command in a certain spot, whether it has any effect to the real format of the post, or is it all custom every time?
No, I would say this is that there is a thing called the universal post generator, and anybody who wants can get in and write their own posts. With that said, about 99% of our customers, rely on us for their posts, and the reason for that, Brian's been doing it for 15, 16 years now, and so he is an expert at writing posts, and he knows, all the tricks, if you will, and he knows, where the areas that could trip you up if you don't get it right, and so he puts a lot of safeguards in his posts. So for most of our customers, we say, hey, focus on what you do best, and that's making parts, and we'll focus on what we do best, and that's, customizing the software, training the software, and supporting the software. And so that's what we normally do.